So let me get rid of this thing so I can see. So this is at the University of California, and there's this giant collection of microscopes, and it goes back to 1994 when when this guy over here, can you see him? My stuff is in the way. It's annoyingly in the way. Can you
You
see
can
all
push
the
it
whole
up
thing?
top. You can grab it and pull it up to the top of the screen if you.
Then I gotta figure out how to get this out of here. This is out of the way. And this guy on the right, he was not 100 years old when I came on board, but he was 100 years old when he passed away in 2015. And Orv and I became really good friends. And Orv, it's a long story, of course, but Orv decided in the early 1990s to donate some money to Cal and to donate some microscopes. And he donated 36 microscopes to Cal in 1994 and 95. And then they just sort of sat there and languished until I came on the scene when I sort of forced the issue and I started making more cases and making a website that you'll see at the very end and so on and so forth. And Orv became very happy with that. And what you see in the background is what I saw when I first visited him in Los Angeles. He had a microscope room down in Los Angeles, and I walked in and I was confronted with this.
It's stunning.
He had 297 microscopes that he bought in the 1960s and 70s and 80s and so on and so forth. And there they are. And I was just like, oh my God, what do I do? And one thing led to another. And we at Cal ended up with about 160 microscopes, the best ones out of this collection. So a little bit more than half of the microscopes that he had. The rest of those microscopes ended up being distributed to the members of his ginormously huge family. And so Orv never accepted a present or anything from me at all. I could never take him out to dinner or anything like that. He and I had a really long history until finally at 100 years old, I was able to buy him a birthday present. And that's him on the right at 100 years old. And what I bought him was a copy of the most famous magnifying lens in the world. And that's a lens by this guy named Leeuwenhoek. And so you can buy a copy of a Leeuwenhoek microscope from the Boerhaave Museum in Leiden. And here he is, 100 years old. He can hardly get out of the chair. But when I gave him this, he knew exactly what to do. And that's how you'd look through that microscope. What he's doing here is what Leeuwenhoek did in the late 16 and early 1700s to discover, among other things, bacteria. So what I thought I would do is go through the some of the collection. Now this collection is, as far as I know, the largest public collection in the world. It's in a very public building on the Berkeley campus, and it's in 4 cases that I had built, and we have close to 170 microscopes, and they span 4 centuries. And so what I thought I would do is go through very quickly and show you sort of just representative samples that are in this collection. Now, this entire collection can be visited like by the public. It's not behind walls or doors or locked anything. You just walk up and you put your nose prints on the glass in front of it and you can see all of these microscopes. And it's in a building on the Berkeley campus that is an undergraduate, it has undergraduate lecture halls. And so thousands of undergraduates mill around these waiting to take their exams, whacking their backpacks into the cases and setting off the alarms and so on and so forth. But they're placards and they look at these things. And so we have Berkeley undergraduates who are 19 years old, who are looking at these kinds of microscopes like these 2 here that are like 300 years old. And it's really interesting. So one of the great things about this Golub collection is that it has microscopes from the 17th and the 18th century. So, the 1600s and the 1700s. It's sort of remarkable. These 2 microscopes shown here, the one on the left is a Dutch microscope, very much like one that was created by this very famous scientist called Christian Huygens. And the one on the right is called a water microscope because it didn't use glass for lenses at the point of the bill of the bird, there's a little hole, and you would put a drop of water there, and that drop of water acted as a lens. And so the lens was, lens-shaped water, and water refracts light just like glass does. And so, in fact, it actually made a very nice magnified image of about 25 power. So this is a water microscope. Now, I'm going to show you these microscopes. Most of these microscopes are unique. There's the only one in the world. There's one of two in the world, and so on and so forth. These two here, the one on the left is the only one in the world, and the one on the right, there's only one other that I know of. So if we go a little bit more, so I want to describe simple magnifying lenses versus a compound microscope, which we'll get to in a second. A simple magnifying lens is a magnifying lens. It's like your eyeball. It's just a simple lens-shaped piece of glass. Sometimes it's flat on one side, but it's always convex. And so if you have an outward curving surface, and that refracts light and will make a magnifying lens. And what we have are all these quite a large number of these quite ancient magnifying lenses. The one on the left, the 1700, is undoubtedly German or Italian, and the one on the right is Dutch. It's made by a very famous guy named Muschenbroek. And these little magnifying lenses were all used for just to look at stuff. The one in the middle, the ivory one, is called a flea microscope because first it's tiny, and secondly they used it apparently to look at fleas. And I can tell you that a lot of these scopes in our collection have samples with them, and when we're in the 17 and 1800s, the samples that are there is always a slide with a flea on it. So I guess they had a lot of fleas back then. If we get a little more contemporary, but we're still in the early 1700s, they put a little screw attachment on it, and it's called a screw barrel microscope. And I show the one in the middle was invented by Nicholas Hartsucker. He's a pretty famous guy, Dutch, of course, with that name, right? But using a microscope like this, he looked at all sorts of things, blood cells and sperm cells and so on and so on and so on. And so Hartsucker in the middle invented this thing called a screw barrel microscope, and then other people, English and French people, put a little handle on it, and it changed its name to a Wilson screw barrel microscope because this guy Wilson put a handle on it. But so now we're getting a little more modern, and the two on the left are made, the one on the far left is ivory, and the one in the middle bottom is made out of bone. So it's like a femur of a cow. And then they started to use metal. So on the one on the right is brass. So if we go to 1600 or so, in Holland, probably a guy named Hans Lippershey put together two simple magnifying lenses, one at the bottom near the object, and that we now call the objective lens, and one higher up in the microscope called the eye lens or the ocular. And so that's the ocular lens or the eyepiece. And with two lenses, one at the bottom and one at the top, you can get multiplied magnification. So the lens at the top multiplies the magnification that was created by the lens at the bottom. So if the lens at the bottom is a 10x magnifier, and the lens at the eye is also a 10x magnifier, then what you end up is with a theoretical magnification of 100x. And so you can have a much greater magnification than you can with this simple magnifying lens like Leeuwenhoek or those previous ones. But look at the picture in the upper right. For 200 years after the invention of the compound or the double microscope, the imaging looked like that. So it was just terrible. So not only did it increase the magnification, but it increased the magnification of the aberrations, of the problems with the lenses. And so these microscopes were terrible. They were terrible until about the middle of the 1700s, maybe towards the end of the 17 and closer to the 1800s. So that picture in the upper right is a circle that I have, was made in Germany. It's 100 diatoms. A diatom are a little single-celled algae that makes a silica shell that is really quite ornamented. It's really, really lovely. And what it looks like is what we see now at the bottom. That's what it looks like through a contemporary microscope. And at the top, that image is taken through the microscope on the left. And so you know, in 1660 or 1700s, these guys would look through these microscopes and see basically nothing. But yet there they were. Now, the beauty of this, and this caught Sue's eye, is that the beauty of these microscopes is that they are in fact quite lovely. They were all handmade and they're really beautiful. The one on the left is Italian, the one in the middle is probably Italian, the left is ivory, and you see they're wonderful works of art. So they're more art than science, more art than engineering. Let's move on. This is a really nice one that we have in the collection. And I show this because this guy, John Marshall, he made this great double microscope. The word double means compound. And what we have in our collection is a unique double microscope. There's only 17 of these in the world anyway, but what we have is a compound microscope that's John Marshall and was modified by this guy here, Edmund Culpeper. So I'm going to show you this microscope because this one is coveted collector's item, and this one is an even more coveted collector's item. So this is called Edmund Culpeper's tripod microscope, and it's obviously a tripod. But let's talk about art here. This microscope is made out of cardboard. The cardboard in the middle is covered with a substance called shagreen, which is flattened and dyed ray skin, you know, manta ray type ray skin. The top part is made out of a hardwood from South America called lignum vitae, and it's so hard it sinks in water and it turns black over the decades or hundreds of years. So it's really a beautiful work of art, but it's a terrible microscope. It has a total magnification of maybe 20x, but its imaging looks like that diatom imaging that I showed you earlier. And on the right, what I'm showing you is what's called the trade card. This is basically their business card, but they would make these cards that describe the things that they made in their shop. And they always had some kind of logo. And Culpeper's logo were the crossed swords. And so you see those in the middle of the trade card. It's quite a beautiful piece of art, terrible for optics, but a beautiful piece of art. Wish I had one of those. This microscope is terrible to work with. So almost at the same time, this microscope, the one on the left, the John Cuff one, was created. And you'll notice that now we can reach into the sample and it has this screw kind of gizmo on the upper support arm. And that screw thing is the focus mechanism. And so over the course of 100 or maybe even 200 years, the makers would increase the mechanical value of a microscope, but they still didn't solve these optical problems. And so as mechanically much better these microscopes were, they still optically were miserable. You will notice that we have these other 4 microscopes on the right side of this slide, and pretty much right after Cuff invented his microscope on the left, it was copied throughout all of Europe. And so the microscope was invented in Holland, but it immediately went to Italy and France and then England and finally ended up in Germany. And once it got to Germany, everything changed. I'll show you those at the end. Here's some German microscopes, and Sue really liked these. You'll recognize this one on the left later on. These were microscopes made by the toy makers of the Nuremberg region of Germany. And they made 3 different styles. And you can see the 3 styles right here. And you have their names below. But those are also works of art. These are functional microscopes, but once again, barely functional. Their focus was all friction focus. And I've tried looking through these and taking pictures through them, and they're exceedingly difficult to work with, but they're quite beautiful things. And these were made out of what's called fruit wood, which is undoubtedly pear wood or apple wood. So it's a hard wood, unlike pine. So it's a hardwood, but it was from a fruit tree. So it's called generically fruit wood. Let's go on here. I got to make sure I got my time. So let's go talk about these for just a minute. These are compound microscopes that were were mostly a French thing, right? So the French took a microscope and put it on a box, and inside the box they put the mirror, and so these are called box microscopes. But what's nice about our collection is that the microscope on the left, this Guillaume-Menard microscope, is the oldest box microscope known on Earth, and we have it. It's not in France. There's a story here. There's a story about this incredibly famous collection that I could tell you someday, but what we have is the largest number of French box microscopes anywhere in the world. And I've been over to Paris and I've been all over, and nobody has more than like one of them. And we've got about 10 of them. So they're quite fantastic. And you notice that they're all kind of the same. Italy got in the business here of box microscopes, but this is the only one I know of. It's mostly a French thing. Let's go back to England now. And so I wanted to show you this maker. So there were some famous makers of microscopes, and we have representatives of all these makers. And this guy here, George Adams, made these two kinds of microscopes, the one on the left in 46 and the one on the right in 1770. The one on the left has a rotating nose piece, and you look in the middle image, you see George Adams. His address was the head of Tycho Brahe. That was his address. So I'm at the head of Tycho Brahe. So he had a picture of Tycho outside his shop. And he invented this microscope with this rotating nose piece of multiple objectives, which was sort of quite innovative back in the mid 1700s. And then he decided to go really total steampunk on everybody, and he created this thing on the right, which is called the variable microscope. And the gear is fantastic, and Sue loved the gear, and I'll show you a picture. She'll talk about this, I hope. So it's quite fantastic. Let's move on. Here's you. Everybody has heard of Charles Darwin. He went on the voyage of the Beagle, and among other things, and he always all these naturalists of that era, the 1800s, they took microscopes with them, and they were microscopes that were like the one on the left. It's called an aquatic microscope for funny little reasons, not that you could look at aquatic animals with these, but for the most part, they were portable microscopes for naturalists. And we have a whole bunch of these microscopes that were all portables, and they were created specifically to just wrap up and put in a box, and then you'd go on voyages or you'd go in the jungle and whatever, and you would do all your naturalist thing. And notice the dates on here. These go from the 1750s, basically the middle of the 1700s to the middle of the 1800s, which is the great era of the English naturalists. In 1800, actually at the end of the 1700s, microscopes got better. They got a lot better because an optical problem called chromatic aberration was solved. And therefore, the image, there's our diatoms again, and look how beautiful they are, right? They're perfect pictures. Microscopes of the late 1800s are as good as they are today with transmitted light. And I want to show you this one here. This is this famous guy named Hugh Powell, and Hugh got together with his brother-in-law Leland, and they created this company, Powell and Leland. And this is the second kind of microscope that you want to collect if you're going to collect it, these Powell and Lelands. And these microscopes are giant brass. They're just anchors. They weigh 20, the one on the left weighs like 20 pounds. They're fantastic microscopes optically and mechanically, and they work as well today as they did back in 1860 and 1870 and 1880. Now we get to binocular microscopes. Notice that these are, except for the one in the middle, these are monocular microscopes, but people have two eyes, and so there are a number of ways to create binocular microscope. This image here shows two different ways. But if you look at the microscope on the left and on the right, you'll notice that there's a straight tube, and then there's a tube that comes out of an angle. There was a little prism that was invented by this guy named Venham, and this prism would split the image, but not symmetrically. One image would go straight and the other image would go out to the right. And so this was the first style of binocular microscopy microscopes. And they're cool because you can use both eyes, but they're hard to deal with because one eye is looking at a tilted eyepiece. But look where we are now, 1800s. These are perfect optical microscopes. They're just odd mechanically. Notice Bullock, by the way, I don't have where it's from, but that was a Chicago company. At the turn of the 1900s, there were about 40 more. There are almost 50 American optical companies, and now there's one. So they've all disappeared to these guys. Okay, so the sort of the end of the story here is that in our collection, the newest microscope we have in the collection is the one on the right. This is made by Carl Zeiss and it's 1908. That's the youngest microscope. And look at its crazy binocular vision. And when the Germans got involved, they changed everything. They fixed the optics, they fixed the mechanics, they created the use of immersion oil to increase resolution. They just blew the water, just everybody out of the water. And so by 1900, there were very few other companies left in the entire world because Leitz and Zeiss basically just had a monopoly because they made such good stuff. And our collection, I actually don't like these microscopes so much because they're just sort of perfect microscopes and they're not beautiful to me. The previous ones are a lot prettier. Now let me show you this. Let's go quickly to this. This is an introduction to Sue's talk. She'll show you her pictures and talk about these, but the microscopes that she picked, some of them I'll show you here, the actual Nuremberg microscope, and there's Sue's picture, and this silver one. I want to tell you about this silver one, the one at the bottom, the French silver. That was Mrs. Golub's favorite microscope. It's a beautiful little French from 1800 or so. And when I visited her once, she told me how much she loved it, but she complained that it developed this patina over the years. And so about every 5 years, she would take Twinkle to it. Anybody know what twinkle is? And so she would take this silver polish and polish the microscope back to silver. Uh, a safety tip here, if you have an antique, never polish it, because if you polish it, you greatly diminish its value, okay? On the right side, there's a funny looking machine here, and that mirror is designed to reflect your hand and your paper that you're drawing on the page, on the table below on the left, up through the eyepiece. And so you can look at your sample and your hand at the same time, and you can make a perfect tracing or drawing of your object. That thing is called a camera lucida. Here's some more of Sue's, which I really love. The wooden guys on the right from Germany and France, and that naturalist microscope on the left, which is obviously from England. Here we have the candle. Sue liked the candle. I took a picture through that microscope with that candle, and this is the lighting that these guys had until I have always asked my students, when was the electric light bulb made or invented? And not one of them at Berkeley has ever known the right answer to this. So that could be another microscope question. When was the electric light bulb invented and by whom? Okay. And on the right, we have some French microscopes on the right, and the Culpeper screw barrel microscope and Sue's beautiful interpretation. And here we have, once again, this is Orv's, this is Adams variable microscope. It was Golub's signature microscope, the Adams variable. And so I want to finish it by showing you what the website is. Oh, that should be HTTPS, by the way. And so this collection at Berkeley is really great, not only because we have so many microscopes, but because it covers 4 centuries of microscopes. And that's my talk. Stop.
Well, Steve, that was wonderful. We'll hold questions till after Sue does hers, but that was great. Thank you so much, Sue.
You're welcome.
Sure, Steve, thanks so much. I learned even more. I have those crazy notes, and now I have even more of them, just for the very things I'm about to talk about. So thank you very much.
You're welcome.
It's nice to see you all. You all know that I'm Sue Fierston. I had this enormous interest in documenting microscopes, in combining science and art. As Steve said, I'm very interested in how the shapes of the microscopes reflect the culture of the time, the playfulness of the time. I also take note that once the optical problems were solved with microscopes, they became much less interesting to draw. And in fact, I only have one of that time after 1900 or so, where microscopes' visual aspect became very standardized. I love how the makers all over Europe, at least, and those are the ones that are collected here, you know, inverted their tubes, tried to match two eyes, tried to capture light, and you'll see that in the slides I have to show you here. I lived in Kwajalein in the Marshall Islands for many years when I was a kid, and that's when I got my first microscope, so it's quite a while ago. I love to use it on the tiny shells that are in the coral sand. You could see them magically, as big as your hand. Of course, in seawater, full of things to look at as a kid. So I think I'm remembering that playfulness when I return to this painting project. Let me share my screen and take you through my slides and my method. I'm going to talk about why I painted them the way I did. So here we go. We'll share. All right. Okay. This is the Simple Botanical Microscope. It's number 44 in the Golub collection. This is painted in watercolor on a surface called UPO, which is a plastic surface. It allows water to run randomly. And one of the things I loved about this project was the contrast between the random water taking the pigment wherever it would go and the precision that I needed to do so that you could recognize this as an object. My method was to go to the exhibit, and Steve let me choose the microscopes I wanted out of the case. I went down to a beautiful office room with great lighting, and I could just sit there and draw them as long as I wanted, no interruptions. It was fabulous. I first drew them in the case, but I drew them all, and then I transferred the drawings to this surface, to this UPO surface. You can see in this one, I was particularly interested in the on-guard aspect of it. It really felt like a person posed with something behind their head to do some sword play. And that's playfulness is what I was looking for in the positioning of these microscopes. So often they corresponded to human positions, or as Steve said earlier, they were just sculpted so beautifully, like that gorgeous ivory microscope we saw. Let's get to my next slide here. This one is the method. I drew in pen. I like to draw in pen because you're forced to pay attention. You can't be nervous and say, oh no, I have to erase. It's not quite right. What you see here is a drawing technique called drawing through. And all it means is getting the volume, and especially with all these round angles, these you know, round eyepieces, round surfaces, round bodies, everything's round in these early microscopes. I had to be sure that the volumes were correct. So, you know, the eyepieces in the drawing on the right had to line up, or no one would believe it. But the thing about this one is, the one on the right, is it isn't quite square in reality. And I had my biggest struggle was to get this one not squared up. You see it squared up. And I had to really work to get it, you know, over time it warped a little, I think. So the painting reflects that, but this drawing does not. And here's the painting of that, the 3 wooden magnifiers. The one that you just saw drawn is this playful one in the upper right-hand corner. Whether it's Italian or German, I love the stripes on the side. I like to think of it as Italian because of its playfulness. You can see up at the top, it's not quite straight because over time that wood warped. They look rather like toys, and they really did fit in your hand. You know, imagine something about 5 inches high. The way that you looked through them and adjusted, you know, sort of what you could see is, for example, in this one where my cursor is, you put your object here on this point, so you impaled it, and then you squeezed that black piece of metal towards the lens to get it to come into focus. So, you know, it was very mechanical. And the same way with the one lying here on the ground. You slid the black pin in and out of that wooden piece to get it close to the little eye. And I just liked how they spoke together, all interpretations of basically what we would call a magnifying glass today. Here's another drawing. This one is of the French silver microscope, my favorite, or at least one of my favorites. I was very warmed up for this drawing, and I had my eye on this microscope for a long time because despite the patina, it was just, if you can see my image, it was just tiny, and it fit exactly in your hand. It was glowing and sparkling. I could see why Mrs. Golub carried it around the house and enjoyed it. For me, the challenge in this one was not drawing it straight, but getting the legs. Those legs are very expressive. Nowadays, we would build very straight, square legs. We're not into these curves. But in those days, legs were like furniture. And furniture of that period had legs that curved in this way. And I had to learn to draw them accurately. Here's the painting of that. In two different positions, this microscope rotates out to something called the aquatic position. And you'll see that over on the right. It's nice to think that it can still do that, even today. Now, some people wonder, why blue? Why not try for silver or use a silver pigment? I've had people ask me that. And the truth is that drawing these microscopes was so complicated. I had to think about how to simplify what I was doing. The drawing itself was very complicated, and I didn't want people to get distracted in a lot of different colors and the idea of, how did she create metal? I just wanted you to see the beautiful shapes. So I stuck to a limited palette that a lot of you have noticed of a classic one of burnt sienna, which is the brownish red, and this French ultramarine blue. And when you combine those two colors, you get everything from black to gray. And here we have a lot of pure blue. And that was enough to simplify all of this against a white background. Well, so what's this? This is a bullseye lens with a candle, two different versions of the same drawing. Before I simplified, like you saw in the last slide, I tried many different styles. I wanted a lot of texture. I wanted a lot of background. I wanted many things. And so this was kind of the artist's struggle, what shows off the microscopes? What am I really trying to say here? So I drew it each time. You can see they're different. They definitely say different things. But ultimately, I realized that this was not a drawing of a microscope. This was a drawing of a lens with a candle. And I had to focus on what it is I wanted to do. So maybe this is for another time. But I wanted you to kind of see the process that I went through. So this painting is what it actually turned into. This one candle power microscope. You see the bullseye lens. I was very interested in getting that lens glass quality right here. And also in lining up this lens with this mirror down here, which is going to shoot the light up into the, I hope I'm saying this right, but into the objective, into the tube. So there was a lot of angles and measuring and thoughtfulness in how I wanted to position this. This was a difficult drawing because of the unusual angle, but I love the challenge of it. I particularly love, and I always save the things I love the most for the end. And I saved the candle because it just had to be very pale and just have a little wick and not get carried away, like I did in the last two that you saw with the whole thing. I had to be controlled. So this was the result. So what is Yupo? I imagine that very few of you watching have painted on Yupo, or maybe none. Yupo is a plastic surface and it does not absorb water. Water has to dry on it, and then it's pretty permanent. So this is on the left, this is my paintbrush and a little drop of water, and I'm dropping some pigment called quinacridone violet into this water, and you can see how it flows. I just took this picture yesterday trying to get this idea across in a slide. So it flows wherever water is, and it doesn't go where there's no water. And that's how I controlled the image that you see as painted microscopes. I put down water in my drawing, and then I drop the pigment in and just let it flow in the drawing. And wherever it was wet, that was the pigment. So here's an example of what that looks like. You know, it can be really wild and uncontrolled too. And a lot of multimedia artists, you know, use this. They do collage, they do all kinds of things because of this randomness. And as I said earlier, I really like that contrast between the random and the precision of the drawing. So here are these two, just so you can see the Yupo. But this is the charm of Yupo. You can wipe it off. Unlike watercolor paper, where you really can't. You can do many things, but you can't wipe watercolor off watercolor paper. You can completely wipe pigment off of Yupo. So you can imagine with the difficulty of the drawings and the necessity for them to be lined up or square or those unusual legs. I did a lot of wiping, and Yupo let me do that. So you can either wipe with water, or if you have a really awful stain, you can use some rubbing alcohol, and that also just takes it back to white, and you can start again. Here's a frieze of 2 of 4 microscopes. I couldn't get it all onto the slide. This is another drawing I did while sitting in the little office. You can see the camera lucida and see how it's beseeching number 207. I just loved this idea of microscopes having personality and inanimate things coming to life, you know, almost like cartoons. And 207 has that beautiful little lens up there. It's kind of keeping the camera lucida back. You know, the whole thing was very, very charming. But in the end, I went with a different microscope, and you'll see that next. I went back to the French silver microscope. I liked the shapes better. And you can see that this is also just shades of gray. I actually changed this slide because I didn't care for the colors. You know, the colors in this painting were hard to get. And one way to tell a good painting is to actually turn it to black and white. And this is what you look for. You look for darks, almost black. And I have that. You look for what's called the midtone, the grays. I have that too. And then you look for either very pale gray or areas of pure white. And I have that too. So it's a solid composition and a solid painting, but the colors I picked just weren't working for me. So I thought it was a chance to kind of tell you how an artist thinks and take it back to something very elemental. It has that same beseeching quality, but not quite the same as the other one. And it's one I want to still play with too, because there's just something about their little personalities. Ah, yes. Here's the Adams microscope. I love, now you turn this key where my arrow is, this ivory key, which you can see is just a very pale burnt sienna. You turn the key and it moves the body of the microscope as well as this long blue fitting according to the gear. And since you know that I save the thing I like for the very end, I saved the gear for the very end with all those little teeth and in the key also, just because they were really the focal point. This microscope looks so delicate that I did not experiment with rotating it to different positions. I didn't want to be the one where it stopped working. So I kept it this way, but I really loved painting this one. This had an elegance that many of them lacked. And I have a feeling it has to do with all the slender parts contrasting to the thicker, bigger parts like the stand, the tube, and then these delicate fittings. So again, this is burnt sienna here, the brown, and French ultramarine blue is of course the blue, and the mix is the other colors that you're seeing here. I confess I did cheat a little bit, and this is a little bit of yellow, raw sienna. This one is the conversation, and Steve showed this to you. Of course, on the right, we have, you know, the very modern, I think it was, let me look at my notes, but the era of 1900 or so, contrasted to the ivory microscope. What appealed to me about this was the challenge of painting ivory, first of all. It does look like ivory, but it was hard to keep it pale enough to be ivory. And then it has a silver fitting here on the back. But what I really loved is what you probably saw first. These two mirrors, well, they're not actually mirrors, they're lenses, and they seem to be speaking to one another. And it's almost like the future calling to the past. And perhaps I should have even given this a different name. But I just like the contrast, and I feel that the one on the right is beckoning to the one on the left. So you can see that in this conversation, I wasn't choosing the microscopes for their historical significance, which is something I did think about at the beginning. I thought perhaps I should take a tour and do the ones that Steve felt were the most historically significant. But it turns out I really gravitated towards the ones that had the most expressive qualities. And that's why I grouped them together. These next two are my last two slides. They are not in Steve's collection. I originally started this project by traveling through the San Francisco airport and seeing, you know, they have a museum right there in the airport, and they had microscopes and scientific instruments from another collector of scientific instruments. His name is Mark Mickalia, and he has a big warehouse of these instruments. This is, as you see, a heliostat sextant. It basically is something that follows the sun and tracks the sun with this big mirror here. And I love drawing this. I love drawing the complicated curves. It was quite large. It's maybe 15 inches high. And I really had to stand at the airport. And I think if my sister is tuned in here, she'll remember the struggles I had standing in the airport, with being jostled by everyone passing by with their luggage and everything, with a sketch pad to try and get the drawing for this one and for the next one. Let's take a look at that. This one is one of my favorites also, the tangent galvanometer. It measures electric current. And 1910 was a time when we weren't quite sure what electric current was, what it could do, what its power was. And all kinds of fanciful machines were created in order to measure this new force, to try and figure out how to harness it and to try to figure out what it did. I loved this idea of the triangle and the circle. It was very difficult to do a perfect circle and fit a realistic triangle in there. I didn't want it to be complicated. I wanted to just be beautiful and ethereal. And this one also was quite a big machine. It was well, here, the actual machine I think was over 25 inches high. And I drew them all I drew all of them about between 18 and 12 inches high. So pretty much person size rather than poster size. I just wanted to sneak those last two in. That is all I have. I have really appreciated this chance to speak to all of you. Thank you, Bronwyn. Let me just...
No, thank you. Thank you for sharing your process and how you approached this project. Let me just put a spotlight on Steve too. Oh, they won't let me do that. Okay, now I have the spotlight on both of y'all. Okay, so now we can do our Q&A section. If you want to raise your hand and ask your question, I can call on you. You can ask directly, or you can put it in the chat box. Richard has a question in the chat box already. I think this goes to Steve. Could you describe more how the Leeuwenhoek microscope worked? What was the screw adjustment for handheld? Where does the subject get placed?
Well, let me see if I can find one for you. I had a slide, but I got rid of it. So ask Sue a question, and in the meantime, I'm going to look for the Leeuwenhoek microscope, and I'll come back.
Okay,
I saw that someone asked in the chat about the UPO, and Bronwyn replied with the spelling, it's YUPO. It comes in pads, and I used huge sheets, 22 by 30, and cut them down to my size. It comes in all kinds of thicknesses, and one thing I was experimenting with was translucent UPO, which you can imagine the layering of microscopes, one on top of the other, but I didn't want this project to get overwhelmingly complicated. But you can see you could play a lot with the materials to try and get the effect that you're going for.
Okay, let's see. Are you done, Sue?
I am.
Yeah, so let me go to here, and then, oh, I have to share my screen again. So this one, yes. All right, so can you guys see this now?
Yes.
Okay, so Leeuwenhoek lived in the end of the 1600s and into the 1700s, and for about 50 years he made maybe 500 of these types of microscopes. They're called microscopes, but they're really simple magnifying lenses. And if you look at this one here, can you see my cursor?
Yeah.
Okay, good. So the microscope on the right is the latest find. Out of the 500 microscopes that Leeuwenhoek made over the course of 50 years, there are only 10 authenticated microscopes known. So if you ever find one in a drawer in Europe somewhere, contact me, okay? Because this is the latest one, and this is a silver microscope, and here's how it worked. This little hole here, right there, that held an objective lens. It held a simple piece of glass that Leeuwenhoek made himself, and it was spherical but slightly flattened. So it's called an aspherical lens. So he did this probably accidentally, but so he took his lens and he flattened it accidentally because he ground it in his fingers, and then he put it between two plates of metal. Here the metal is silver. These three microscopes here, the metal is copper. He made a couple of gold ones, half a dozen or maybe a dozen silver, and the rest of them were made out of sorry, not copper, but brass, okay? And so now you would impale your object on the head of the pin, and then this part here, it doubles as the handle, and it's screw threaded, so it would move the sample up and down, and this handle right here connected to this sort of elaborate sort of rectangular piece of metal, you'd screw in and out, and that would move the object in and out and for focus, and this moved the object up and down. And so then from the other side of the microscope, as I showed you in Golub's picture, do I have that here? Oh, I have this in this other presentation, but you would hold that close to your eye. Now, the focal length of this lens in here, these lenses were 1 millimeter in diameter, right? So imagine making a glass sphere by hand 1 millimeter in diameter. This was his incredible genius, right? It had such a short focal length that you had to put this inside your eyelashes. And now you could take and see a magnified image. Now, the microscopes like this were maybe 10x or 20x. His microscope, because the lenses were so small, were 285 power. So imagine a hand lens that magnified 280 times, and that was some of Leeuwenhoek's, not all of them by any means, but some of Leeuwenhoek's microscopes. And with these, he would be able to see bacteria and fungi and stuff like that. So that's the whole microscope. This thing itself is literally like maybe 2 inches tall. I've bought 3 of these myself, right? So, and donated them to the collection. And so this is one here is a copy of this authentic number 10. This one I just bought. It's kind of a coarsely made copy made in Portugal in the 19th century. This is one I bought at the Boerhaave. You can buy one of these yourself. And this is Orv's original 1968 copy. They're all copies. The collection does not have, we do not have authentic Leeuwenhoek microscopes, which is a bummer. It's the only copy we have in the collection, but they're so important, I decided to put them in. So that's how they worked. You can buy
Steve,
one yourself. What?
Steve, I have a question because you said that when he looked through that to see the bacteria and what the image, was it as clear as, how clear was it? Was it still bad or?
He wrote 550 letters to the Royal Society of London, right? And in some of the letters, and in many of them, he had drawings of the things that he saw, and the drawings of bacteria that he drew. Let's see if you can see this. I have a picture of it. The drawings of his bacteria were like little dots. So, the guy, I don't know, can you see? Yeah, so this is out of Leeuwenhoek's, the one on right here, this one. Those are his bacterias that he drew. And they're just little rods or little dots. And one of them has a little dotted, so it shows that it was motile. So it shows that it sort of swam around. So he just drew these things. And when he looked at stuff that was liquid or partially liquid, he would glue a piece of mica to the pin and then put the liquid on that pin. And when stuff was solid, he would impale it on the pin. So, and the amazing thing is that he made 1 microscope per sample. That's why he had so many microscopes, 500 of them or more.
That's crazy. Now, Sue,
It's crazy.
Sue, I guess I was a little bit confused about the Yuba stuff. It seemed like it was so out of control. You put watercolor, you put that, it's all over the place. Did you do it? Were you wiping to get the shapes of the picture? So like you had a whole bunch of the color, then wiping it to get the structures that you wanted? Or how would you contain the chaos?
Well, I don't know if you remember that picture I showed with the paintbrush and a drop of water on the paper. The water will sit on top of the paper in any shape that I make it. It'll sit right on top there, like a drop of water on a leaf. And so I drew the drawing in water, and then I dropped the color in and let it flow. And then when it dried, I went back and added more color and water on top. And if I made a mistake or if it did flow in the wrong place, then I wiped it and started again. Does that help?
Yep, that helps. So you were actually just drawing with the water.
Drawing with water.
And then the color was secondary.
Yeah, the color was secondary. And I learned also that if no matter how much I might like, there are certain colors, even certain yellows, that are very staining, meaning they're going to leave their mark behind no matter how much you try to get them off the paper. And I had to stick with colors that did not stain the paper because the drawings had to be so precise. They're not as precise as botanicals, but they're pretty precise. And I had to be able to go back to white and create that angle to make it believable and recognizable. So it was all with water, all with a bead of water. So I needed a really kind of angled light coming in. Couldn't just be straight down because then I couldn't see the water drop at all.
Did you use a microscope to make your drawing?
No, I didn't. I didn't, no.
That would be very meta. You're using a microscope to draw a microscope or to paint a microscope. That was. Secondly, I love the name Orv. I want to name somebody or something Orv. I think that that is a great name.
Well, Orville J. Golub, but yeah, Orv was a character actually. I asked him once why he collected microscopes. You know, because I would go down there to he moved up to Carmel, and he has a house in Carmel that I still actually visit. But I asked him once, I described once optically, and he kind of went somewhere else. And so one day I asked him why did he buy Microsoft? What was his whole goal? And he said, and Sue, you'll love this. I bought microscopes because I loved the way they look. And
Uh-huh.
it was only that.
Mhm.
And this explains first
The
off the
whole
era
thing.
that he bought it, but it explains like the whole thing, right? And
Yeah,
explains it's
yeah.
heavily in the early centuries where microscopes were. You know, there was a question, what's up with the bird's beak on the Grayswater microscope? I've wondered this myself. It's crazy. It's stupid to have a pointer curved outward like that because no sample gets impaled, it just slides right off. And so it drove me crazy, but
Mhm.
it was totally for art and totally just for looks. And all
The
of the
other, oh,
microscopes were just so pretty. They were heavily weighted towards beauty and less towards, you know, sort of size.
magnification. The other fellow that, who, who I drew the other two from, he said basically the same thing. He loved the shapes. He was looking for interesting shapes. He was an engineer and he was all about the shapes. He didn't really care if they were efficient or the best in their group, but if it was a beautiful sculptural shape, he was all about that. So that fits.
Somebody asked me a question. How far did Orv travel to get his hands on his mic? How far did Orv travel to get his hands on this collection? Yes, okay. So Orv would buy, he was active in buying microscopes during the 60s and 70s, and he would buy whole collections or partial parts of whole collections. There were a few individual microscopes that he would buy, but mostly he bought collections. And he was one of the great buyers of the world at the time. And so the sellers, especially in Paris, there was one seller named Elaine Brieux who contacted Orv. And as I said earlier, I have this great story. There's no time to tell it, but it has to do with this fantastic Paris collection called the Naché collection. And Orv had his hands to buy it, and he actually tried to buy it, but then Paris, France took it away from him, and there's a lot of dramas. You know, Humphrey Bogart works in there somewhere, and so, but Orv wouldn't travel anywhere to buy microscopes. They actually came to him, and back in those days, wow, was it different? He'd get a letter typewritten, would you like to buy this? And then he'd think about it for a month and then write a letter back, sure, how much? And so each sort of conversation would take months at a time. And the Naché collection took probably 6 months to sort of finish off that whole business deal. And that's kind of how he did. When Orv was 98, 2 years before he died, his daughter contacted me and said he wanted to get his hand back into buying microscopes again. And I'm like, great. So I contacted a couple of sellers, friends of mine in Europe, and they came back a few months later and they said, here's one here that's really beautiful, et cetera, et cetera, et cetera. So I bought it for Orv. And then I drove down to Carmel where he was and I assembled it for him, and that was great. So we have that microscope now. But yeah, so he didn't go there. They actually came to him. Except the one time he went to Paris. Could early
All
microscope be
right,
used to
Bill has a question. Yeah.
Yeah,
Could
so
early microscopes use the projected image of the sun on a paper?
um telescopes did that. I have a telescope that made in 1840 that has a super dark opal glass that you could look at the sun with and project it
Hmm.
onto a piece of paper. There are a whole genre of microscopes called solar microscopes that you would put in a cupboard in a window, and they had a mirror outside, and it would shine the sunlight through the sample, and then the sample would project an upside down image on the wall. And those are called solar microscopes. And people would apparently set up chairs and they would go to, you know, pond scum night and they would look at pond scum projected on the wall on the other side of the room from them. So those are solar microscopes. The Golub collection, we must have a half a dozen of solar microscopes. They seem, once again, monumentally dangerous to me. So
Steve, do you have a favorite in the whole collection?
yeah, that Italian one. I like that Italian one.
You do.
Um, yeah, the beautiful the earliest one in the collection, probably the oldest one, pre 1664. Um, it has only two lenses in it, and it's the ivory one, and it has such an incredibly beautiful shape. It's just and it's literally like 6 inches tall. It's one of a kind. There's nothing like it in the world, and so that's actually my favorite.
I have a drawing of it here.
Yes, I love that scope. Yeah, I just adore that microscope. It's just
Yeah.
I've looked at it under fluorescent light to prove that it's actual ivory, and I've looked through it, and I've actually taken a CT scan of it. I needed to know how many lenses were in it because I suspected it was earlier than what Orv thought. And so I brought it to a hospital and put it on the pillow, and I CT scanned it, and I have a three-dimensional diagram of it, and sure enough, it has only two lenses, which is like
Huh.
incredible. The history of the microscope, a third lens was put in there in 1664, and it was so great, so advantageous to light collection that every microscope after that had it. So if you have one without it, it's really quite meaningful. So I redated that microscope to about 1660. There aren't a lot of microscopes that are mid 1600s that are left. I mean, they just
Wow.
have all disappeared. So,
Yeah.
but I love that scope because it that one calls to me. That's a beautiful microscope.
That's
So
a beautiful object. Yeah. So they
Steve,
carve.
did you?
Oh, go ahead.
Go ahead. Steve, did you mentioned before that you've tried to take images and look through all the microscopes in the collection? Are all of them still functional in some form or fashion?
yeah,
Have you been able to extract images from them? Are those images that you've taken part of the website?
yes. So the answer to all that is yes. If the microscope has glass left in it, and some of the microscopes we have, the glass is gone. Very few. And then obviously they're just a pretty tube, or maybe not even pretty. But if the microscope has glass in it, then I have this whole tripod system set up in a little tiny camera, and I take pictures through it to see what it looks like. And all of those are on the web. I've been doing this website since 2004. And every month from 2004 until, in fact, even now, I feature one on the website. It's called the MOM, or the Microscope of the Month, and I feature it. And COVID kind of killed that a little bit, but I still feature one microscope every single month. And when I do that, I take all these pictures of the scope and I take it apart and I make sort of diagrams and I try to figure out how it worked. And then if I can, I take pictures through it. So there are a lot of pictures through the microscopes. And as Sue pointed out, the newer ones, they're boring. They're just scopes. I, 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 I ran a microscope lab at Cal that had just fantastic microscopes that, made pictures like that. And I'm like, well, those are great, but it's not pretty. It's
Not
not,
art.
not
Yeah.
they're not compelling. They're not art at all. So yes, there. If you go to the website, that website is very primitive in a sense of it's not. There's nothing. There's no movies on it. It doesn't move. It's not glitzy. But there's thousands of pages and there's descriptions of everything in this collection there. Someday I'll turn that into a book, but someday.
Yeah. Sue, where if we wanted to go see the prints in person, or the paintings in person, are they up anywhere, or is
No,
there a
they're
different?
not right now. They were at the National Institutes of Health last winter for 3 months. They were hanging in the clinical center. And I thought about bringing one to the sellers night that the National History Group is having. But no, they're not. I'm hoping that they could be exhibited somewhere else. just sent off a query to the National Academies of Science, which does have an art/science program and encourages talks like the one we're having right now, where science meets art. But you know, who knows? Who knows about that? I can imagine them going to, certainly to hospitals. I can certainly imagine them going to a local gallery. One problem that I face, you know, once you frame them, is shipping across the country. So, you know, there's some logistical things, but I would love to put them up and have them be seen by other people. That would be awesome.
Oh, I hope you do bring one to Museum Store Sunday on December 1st. So that would be great.
Thank you.
And are you continuing on this same journey with the antique instruments? Do you have something else up your sleeve in that direction? Or are you moving on to something completely different?
I would love to do more of them. When I saw that room of Mr. Golub or Dr. Golub, when I saw that room, I was like, oh my goodness, look at all these old friends gathered here, all speaking to each other, all beautifully lit. I just felt it all come back to me. I think, though, that microscopes, people are not thinking much about them. And so it's one thing for me to paint them, but it's another thing to get them out into the world. And I think until I can get this group out into the world, I don't want to paint a lot of them. I'd love to draw them. And there are lots of collections all over the country, but I'd like to find a beautiful spot for these beautiful things and have a chance to talk to people about, you know, why they're so awesome. That I think is the first step.
And for if you're anybody who's listening and they're artists out there, you know, when the museum is open, you can come in there and there's all kinds of wonderful things that might spark your creative, be your muse, and you can sit down in the museum with your pad. We don't have crowds with suitcases bumping you out of the way. You can have some quiet time with the collections and draw away.
Yeah, I can testify to that. There's lots of beautiful things there to draw. I've drawn some of the fossils.
All right, do we have any other questions? If you want to put them in the chat box or raise your hand, you can ask directly. Well, Steve and Sue, this has been an amazing discussion, presentation, exploration. Thank you for giving us a peek inside the collection and a peek inside of your creative process as well. So it's been a real special evening with you both. I appreciate the time.
My pleasure, Bronwyn. Thank you.
It's been great. Thanks for asking me.
And me too.
And everybody, we'll hope you see you next week when we're at the World Series of Birding and see how our Maryland team of youth did in that competition. Until then, stay well, stay curious, and stay outside. Bye, everybody.
Goodbye. Thank you, Bronwyn.
Thanks, Sue. Thanks, Steve. We'll see you next month, I guess. Or
yes, we'll see you next month. Yep.
Okay.
Yep. Steve, it's awesome to see you. Thank you. Thanks for doing this.
Oh, you're welcome.